Hello world, this is Leo. In this video you will learn how to do 2D character animations in Godot and how you can extract all your character movements from a single sprite sheet like this one. At the end I will show you a bit of code to bind these animations to your movement, but let's leave this for when we get there. If you are ready, let's get some experience points in and level up as game devs. Animations in Godot can be done in two ways, through the node AnimatedSprite2D and through the AnimationPlayer. The AnimatedSprite2D is simpler to set up, so let's start with this one first. Later we will work with the AnimationPlayer and see what advantages it holds over an AnimatedSprite2D. Let's start by creating the AnimatedSprite2D node. And the AnimatedSprite2D node is almost like a sprite. He needs a texture that we can add to it. If you click on this sprite frames which are empty, we add new sprite frames to it, which enables us, if we click on it, to have these sprite frames down here below. There might occur cases where you have sometimes all of your frames, all of your pictures as single data points, as single PNGs. For the most of the time, what you would have is probably a sprite sheet. Both of them work with our animation player. You can, for example, if you have them single, just drag and drop them in here and do that with each of them individually, or simply in bulk, however you like it. And then if we play our animation here, you can see that it's already moving. So as easy as that, you can create an animation in Godot. Let's call this one single. Let's create a second one. We create a new animation and call this sprite sheet. But we can't just drag and drop our sprite sheet in here because this is what would happen. What we would do is we select this icon here to add frames from a sprite sheet. And then we find our sprite sheet in our folders and open it up in here. Now what you find is that on the horizontal axis, you have 8 different frames. And on the vertical axis, you just have 1 frame. This is what we have to represent here. 1 frame is for the vertical and 8 frames we have on the horizontal. And now they are sliced up neatly. Now we need to select all of these and we add the 8 frames to our animation and we have basically the same result as before. Awesome. Now let's move this a little bit down here for later. And now let's jump into our player character and see something a little bit more complicated. What we're doing now is we'll take this huge sprite sheet here and we will make animations from it. Reference to the sprite sheet is in the link below. I took it from a creator on itch.io because I am not capable of doing such stuff yet. And what we will do now is the same thing. We look for an animated sprite 2D. And in the animated sprite 2D, we will do the exact same thing. We add new sprite frames, we click on it again, and then we want to go into our necromancer and we need to slice and dice this up again. So this one here has on the vertical axis 1, 2, 3, 4, 5, 6, 7 different frames. So we would give it 7 here on the vertical. And then we have 17 frames that are going into the horizontal. If we dice them up like this, we have a neat result. And now we can start selecting the frames that we want to animate, like before with a cat. Now let's pick all of these frames. I add 8 frames to, and I haven't named this yet. I call this idle. And if we go close enough and we play our idle animation, you see it's already working. And for simple animations like this, I think the AnimatedSprite2D is really, really cool. We can quickly add new animations. Let's call the second one walk. And we do the exact same thing. We give it again 17, we give it here 7. And what we can do is we just select again the frames that we want to use. And we have a walking animation. And we can switch between these two. The naming here is important because later in the code, if you want to switch from one to another, you will have to call this name. They should represent what this animation is supposed to do. Now let's make a third one. We will have later in our code 3 different states: attack, idle, and walk. And I am going to add now the walking animation to this. Hit enter, make it smaller, and this is the attack animation. This one has 12 frames, 13 actually. And if we play this one, you see it also works. The speed of the animation might be a little bit slow. If you want to have this playing quicker, you can just double the frames per second that he is playing. Now our animation is twice as fast. Look at that. And it also does only do this acceleration on the one that we have selected. If we go to another one, it still remains at the defaulted 5 frames per second. Cool. Now, through this, we have set up our 3 animations: the attack, the idle, and the walk animation, using the animated sprite 2D. Now, what we want to do is do the same thing, but using the animation player. First of all, let's get this out of the way, and we will create a new sprite 2D first, and then we'll create an animation player. These two are going to interact together. So first what we need to do is to give a sprite what we want to animate. And here again, we use the big sprite sheet that we had before. And we will reduce this to the very first frame that we have inside of this whole sprite sheet. We do this in the animation section here underneath the texture, where we can say how many frames in horizontal and vertical does our sprite sheet have. And we know that these were 17, and we know that these were 7. And just like this, we have reduced everything to just one single sprite. Now, this might be a good moment to explain how the sprite sheets work and how this animation of the sprite 2D is working. Let's call back up what we had here before. Drag that a little bit down here. Now what we have here is a cardinal system, just like our movement. We start at 0, 0. This is row and column 0. So on horizontal, we have frame 0, and on vertical, we have frame 0. And you can see that here on the right side as well. If I increase my frames, I go 1 frame up, I jump to x1. This is here, and y stays as 0. And I can keep going, and you can see we jump here on the x coordinate to the right. Now, this goes as far as the point where we have now our 8th frame. So we start counting at 0, 0, 1, 2, 3, 4, 5, 6, 7. And if we go beyond that, he picks the next frame, and we see it's empty. And we can keep going like this until we hit the end of this whole sprite sheet. Yeah, so this would be the number 16. Look at what happens down here. If I go one more, the next frame that he selects is going back to the beginning. We have now x0 again, but y increased by 1. If you select here the y2, and he's going to move to this frame down here. And you can see we are at frame 34. This far just for explanation on these frames. We are currently, if we are going to 0, 0, at the very first position of our sprite sheet. Now let's hide this again. I think that's enough for explanation. And we set now the animations for it. Now we move to the animation player. If our animation player is not exactly below the sprite that we want to animate, we might have to select the root node that we want to use. In our case, it is properly set, but you can do that here on the right. And to start an animation, what we need to do is to click here on animation and click new and give it a name. So this one again will be the idle animation. In this idle animation, we have now empty animation tracks, or actually they're not even empty, they're not existent. We can add tracks to this to do a bunch of stuff with it. To have the same result as in our animated sprite 2D, what we'll have to do is we go to our sprite that we used before, and you see, since we added an animation, you have now these little keys here appearing. And what we can do with it is we can click on this, and he will ask you if you want to add a new track down here below into your animation. We say yes, we create a new track, and he also automatically puts the first frame in it. Let's up this by 1, go to the next frame, and we can click here again on this little key symbol so that he adds to us track that we already have, the next frame and the next frame and the next frame and the next frame, until we have all our frames in here that we had previously as well for our animation. Now we can play this animation and you can see that it moves up and down, wonderful. And we can loop this animation if we click the button here to the right. Let's play it again. And you can see, the movement of this one is a little bit janky. He pauses for way too long. The reason in this is, and let me zoom in a little bit here, we are adding a frame every 0.1 seconds. And we have 8 frames, so we come here to 0.8 seconds. The last frame that we start is at 0.7. So if we reduce our loop time from 1 second that we have here to 0.8, the animation will become smooth. The reason why it does not move smoothly with 1 second is because he has 2 empty frames that he adds at the end of this loop. Just like that, we have already created our first idle animation. Great so far, no difference, except it's a bit more clicks, and in this case the animated sprite 2D would have been a bit quicker. Let's add a new animation, and this one is going to be walk. And we do the exactly same thing, only we have to now, if we pull up our reference here again, we have to now jump 1 down in the Y. Yeah, so the next frame that we want to use is here on the Y coordinate 1 and on our X coordinate 0. This is where we start our new animation. And now we can simply, just like before, let's roll this back, add the new track and add the new frame onto here. And we keep repeating the process, and you can see that we are updating here live as we keep getting more frames. Let's reduce the animation to the same value again, because they have the same length. Both of them are 8 frames, and we are doing 0.1 seconds each frame. And if we give it a loop, and if we hit it a play and we scroll in, we can see that we have a neat loop of our walking animation. Floating would be more accurate. Now let's do the third one and be done with it. And we call this attack animation. And we do exactly the same thing, only that I will increase the size here of our track a little bit to 2 seconds, because I know we have a few more animations that we want to push in here. So let's see how many these are. We do the same thing here again. We go back to the coordinate 0 for our X value, and we go into third row, which is starting our attack animation. And here we have frame number 34. And from this one, we want to go on and create more. Now, see, I did not reset my marker. I have to reset it back here. I added a frame somewhere where it shouldn't belong, but no issue. Let's move to the next possible frame, and we add the next frame. So 34 was the first one. We already added it. Let's go with the next one and keep hitting this button until we have empty frames. Cool. I don't need the empty frames. And let's zoom in to see when is our last frame. So our last frame starts at 1.2 seconds. That means at 1.3 seconds, we want this to end. We loop, we scroll in, get rid of this, and here you go. This is our attack animation. Very cool. Now we have all 3 animations, the idle one, the walk, and the attack that we also had in our animated sprite 2D. Now what we can do here is adjust speeds in both of these animation players. First, let's adjust the idle speed, for example, for our animated sprite 2D. We can do it as simple as increasing the frames that we want to play per second. With 10 frames per second, we are already pretty close. And you can just set it to the speed that you like it to have. For our animation player, the way to adjust here the speeds is a little bit more complicated. We could, for example, reduce the snapping of our single frames to a different value like 0.5. And if I then drag all of the ones a little bit closer to where they should be, we see that we have a quicker animation, and we will reduce also the loop time to 0.4, and we have doubled the animation speed for this animation, though I think it's a bit too quick. So let's revert all of this, and now we look at something more special. And that is, what can an animation player do what the animated sprite 2D cannot do? Let's get rid of the animated sprite 2D for a moment, and I will show you something really, really cool. And that is that inside of our animation player, you can animate different objects at the same time. You can also alter the properties of the animated objects, and you can even call functions. Let's keep it simple. What I want to do with you, let's stop this animation for a second. What I want to do with you is I have gotten myself this beautiful little hat here, and I want to give this hat to my animation. Let's make this a little bit smaller so it fits better. And let's go over it. Obviously, if I play the animation, the head sits in the scene without being animated. It is just standing there and not moving. We want it to move alongside the character. The benefits of this is that, for example, you could hold a weapon or a tool, and you have it animated together with the animation of the character. And you don't have to create a sprite sheet for your character holding each of these individual tools, because that can blow up in scope very easily. It will be a nightmare. So for the hat, this one, if you go inside of the animation here and inside of its transform, you see, since we have an animation player in the scene that is running animations, we also have these little key symbols here to the right, and we can use them in order to make new tracks inside of our animation. If I, for example, use the property of this hat, so I don't even access the sprite texture or animations or frames or anything, I can also access the properties that it has, like rotation or the position and the scale of the hat. And if I click here and add a track like before, you can see that I have now the hat and its position that I can mess with inside of this animation. Let us position the head on top of each of the frames. Let's try to be quite precise. So let us now try to have this head always on top of him. And I want it to be very close on top of his eyes. Let us alter the position so that it's right on top of his eyes. And we hit the keyframe here to add the key position. As you can see, values are updated in here of 175 to 77.205 as coordinates. Let's go to the next frame where we've moved a little bit up, and we move our head up as well. Put it just below the eyes. And if we hit the key here, you see that there's another dot appearing, and he has a new position value. We keep doing this, and I speed up the process a little bit. Awesome. And just like this, we have set up an animation with a different object that is now sitting on top of this animation. If we play it now, though, something weird is going to happen. As you can see, the movement is very janky. The reason for this is not because we didn't set the frames properly, but it is the linear update mode that we have down here in the options. We want it to set to discrete. Linear means that it's going to move from one frame to another in a linear way. Discrete means it is going to snap from one position to another, just like our animation frames, and it is going to look much better. See? And isn't he a beautiful boy now? Good. Though this we would have to do for all of our animations. So I will go over and do this real quick, and I'll be back when it's done. Awesome. And with this, we have 3 beautiful animations where we have suddenly a head on top of our character. The benefit of this approach is that we can easily exchange, even in a code on runtime, the sprite for this head, and as long as they have a similar position inside of the sprite, what we can do is just simply drag and drop and suddenly give it a different head, and it looks just as awesome. That is a simple trick on how you can create costumes or skins for your characters. They are interchangeable. Okay, awesome. We have our animations, but how can we bind them together into our movements? As you can see, if we run around left, right, up and down, we have no animation playing whatsoever, not even if I click with my mouse to do the attack. Let's do that real quick inside of the scripts. First, let's go with the animated sprite 2D, and later we will then use the animation player for it. Let me create two variables real quick. The one is the animated sprite, and this is going to reference our animated sprite 2D. And the second one is the AnimationPlayer, which is then our animation player. Awesome. Of course, these shouldn't be simple variables. These should be onReady variables so that we can load these resources once the node is created and ready. Cool. We have our simple movement script here that you might remember from our last tutorial about movements, and we will expand on this. Before I want to move, I actually want to have an update on my animations. So we call it just that. And we will then create that function so that we can call it. What we are trying to do here is to create some kind of a state machine. A state machine is essentially a piece of code that will switch around your different states of behavior from the character or the NPCs, enemies, etc. And they can become really complicated. We are going to attempt to have a very simple setup with just these three different animations. But just so you know, state machines can go beyond the scope of any video if they really want to. So we have three states in which we want to switch in between. The one is the idle state. The second one is the walking state. And the third one will be called attacking state. Right. And what we want to do is if we leave one, we want to start the next one. But first, before we do anything, I really need my first animation to even start before I can switch in between them. So that is what we will do. We will have the function and we call the ready function. And when we instantiate this character, I want our animation from AnimationSprite to play me the idle animation. And the same from the AnimationPlayer, I want to play the idle. Cool. This way, both animations start right away. Now let's implement the logic on when do we want to be in which state. The idle state is the state in which we are not moving. And we are not moving if our velocity is 0. So let's script that real quick. If our velocity is the same as vector2.0, then what we want to do is we play the idle animation, just like that. And if the other case is true, like if velocity is not 0, what we will do is then we want to play the walk animation. We'll be adding a little bit more later, so bear with it for now. Now for the attacking state. This one is pretty simple. We want to enter our attacking state whenever I hit my attack button. So my input is action pressed and it's attack. Then what I want to do is to play, whoops, that's a little bit too much. What I want to do is play my attack animation. With this, we potentially could start, but the problem is the attack animation will be overwritten by these two as soon as we enter the next frame. So I can show you that. It is not going to show. And we will see another problem that we have here, which is that if I move to the right, it looks good. But if I move to the left, I seem to go backwards because we are not flipping our sprite. If I hit the attack, you can see him doing something. He's kind of resetting in his frames, but he's being overwritten right away. So he cannot perform the attack animation at all. Now, what we have is a direction from our script in the move character function. We have a direction and we declared it also in the top. And this direction we can use to tackle the first problem, which is that we're walking backwards. And it is done very easily. Like if our direction is smaller than 0, then what I want to have is my animation sprite, and there's something on the sprites innately, which is offset, and you can flip them horizontally. If we look at that here, you can see that he turns around if I enable that. And this is a Boolean check, like it's true or false. So what we are going to do in our script is to set this flip horizontal equals to true. What we then do is else. What we do is flip it to false again. Now this should already handle our vector direction.x is smaller than 0. Now it works. If we go into the left direction, our direction.x is going to be negative, and then we are going to flip our animation, else it flips back. Now onto our attack animation. This one is a bit more tricky. As long as we switch between two states, that is still manageable. We can have either one or the other. But if we have 3, we have to exclude all the others in our scripting logic. And one thing we could question ourselves is, do we actually want to move while we attack, or do we not want to move? We will decide to stop moving when we attack, so it doesn't look all janky and weird. And to check on this, what we will do is add another condition to our walking state and idle state switches. So we want to switch only if we are currently not attacking. And we write that in here by our animation sprite dot animation currently is not, and here we can just give it the name of our animation, which is attack. Then we want to go ahead and move into the idle state. Else, if we have velocity and are moving, and our animation here as well is not playing the attack, then we can switch into the walking animation. And to prevent them from moving, we do pretty much the same check up here. Write an if statement for the update of our velocity, and that is if the animation sprite is not playing the attack animation, then we will update our direction. Else we will say velocity equals vector 2.0, and we will not be able to move. Let's see if this really works. First of all, the sideways movement, left and right, should now show perfectly so that we can switch the sides when we move. And now if I hit, so we see that we actually have a little problem here. We are not escaping the animation for our attack. How can we do this? I go into my animated sprite frames, and I set the attack to not looping. And if we try this again now, it worked, but we're not starting our idle or any animation anymore. So what we could do in our update animation is to just say if our animation sprite dot is playing. If it's not playing, then we will start the animation. So it's anim sprite dot play, and by default we will always just play the idle. Now through this, finally, after doing the animation once, we go back into the idle state, and if we walk, we actually override that directly to keep moving and walking. Now this is how you can set up a simple state machine inside of Godot. Just note that this is probably not the best practice and not the best way to do it. I know some of you will roast me out there for this ugly code that I wrote here. Feel free, let me learn how I can do better, and let's get some experience all together. Now I will create a second animation, which is then being called _2. Why not? Let's create a new function. And what we will do now is pretty much copy what we have established here, paste it in here, and make this one now ready to use our animation player. So our animation player, we have also saved it up here. I'm going to copy this one in, and everywhere where it says animation sprite, we will have to exchange it. You can highlight multiple spots in your code if you hold the Alt button clicked, and we can just exchange all of them with a paste at once. So the animation player update animation already exists. Let's correct this and we can go and start working. First of all, an animation player that we have referenced, we cannot flip this. What we could flip is the sprite itself. Remember, this is an order for our sprite to flip to the left or to the right when we move. I'm also going to hide our animated sprite 2D, and I'm going to show our animation player sprite 2D with his beautiful hat that we gave him earlier. We have now a few things to change. The animation player does not have the shortcut to the animation, but what we would have to put in here is the keyword current animation to get the animation that is currently playing. And we would have to do the same thing up here where we want to check if our attack is currently playing. And that is basically all the change that we have to do here, I think. Of course, we have an error because this one should be also player. We did a spelling mistake, classical. Not that I'm surprised. And now we have our animation player doing the animation. We can move left, we can move right. We see that there's something weird happening with the top hat. And well, if we play our attack animation, we suddenly can't move anymore because this one is looping as well. We kill the looping of it. Now everything works. Now we only have the one slight issue that our head is not centered on our player when we move to the left side because the sprite is not perfectly centered. This is something we can easily do as well. So inside of our function here, where we also flip our sprite when we move to the left or to the right, what we want to do is we take our head and we take the property of the head, which is the offset here, which is moving it a few pixels to the right or to the left. So let's take our offset.x, and I think having it at -3 should be doing a trick. Now let us do the same thing for the x. We set it back to 0 once we flip the sprite back to normal, and then let's see if it works for us. So here we go. Going to the right is perfect. Going to the left, I don't know if you see anything. I barely notice a difference. I think it looks really good. Thank you so much for watching. And as always, much love. Keep creating games and ciao, ciao.